Okay, I'm gonna pull up in a minute an animation here of uh, this little circular thing with a red dot and a blue dot. What we're going to talk about is something called the angular frequency. Now, what I want you guys to pay attention to is what the way you can kind of view this is the red object is an object going in a circle, all right, and the blue object just represents the horizontal component of that. In other words, it just represents the motion going left and right of the object going in a circle. So, what we can view this rotation as is something referred to as an angular frequency. So, if you also observe the rate at which the blue object moves, this is very similar to the spring mass system where the mass goes back and forth, oscillates between two parts. Uh, the far ends are the amplitude, the middle is the equilibrium point. So if you look also in front of the room, probably between um, Jenny and Abby, there is a turntable with a blue marker on there. If you shut the lights off in the room and take a flashlight and shine the flashlight on the marker as it spins on the whiteboard, you should see the shadow of the marker just go back and forth along the whiteboard. That also will mimic the motion. But for now, we're going to look at this in terms of angular frequency. So angular frequency can be related to angular speed. If we look at this and we apply this to the red object for one cycle, okay, in one cycle, the number of radians is 2 pi, and the time for one cycle is the period. So we can get the angular frequency is equal to 2 pi times t, or I can write this as 2 pi times 1 over t, or 2 pi times the frequency. This bit of information is going to be helpful a little bit later on. I just wanted to introduce it here. And I also wanted to bring to light the fact that the blue dot in the simulation also follows the same rules as the simple harmonic motion of the spring mass system. If I look at the motion diagrams, as the red dot travels in a circle and the blue horizontal component moves back and forth left and right, the motion there gets faster through the equilibrium point, then slows at the amplitude, and then gets faster back through the equilibrium point and slows and turns at the amplitude.